Hello everyone. I'm Raji. Last class we have seen about what is supervised learning, overfitting, and underfitting. The basic thing of supervised learning is for the model learns patterns from training data, and the goal, the learning objective is definition, differentiate, analyze, and apply of concept of overfitting and underfitting to identify techniques to prevent overfitting and underfitting. So analyzation is for how model complexity affects generalization performance. So here we have seen the introduction of model fitting also. So under fitting we have seen last class itself. So it is a basic thing of fails to capture underlying patterns and performs poorly on both training and test data. So it is associated with high bias, so it will causes insufficient features, oversimplified model, and inadequate training. So bias, variance, and trade-off itself we have seen in last class. So here there are graphical representation will shows the what is model complexity and error with optimum model complexity, and the bias square and total error, which is a bias squared and variance. And the bias is error due to overly simple assumption, and variance is error due to sensitivity to data fluctuations. So here it leads to decrease bias and increase variance. So minimize optimal point is to minimize total error. So today in this lecture video we are going to see what is how will preventing the underfitting. So here five key steps to follow to prevent the underfitting. So first thing is which is training, testing, and data validation, and choose a robust algorithm and improve the model and ensemble learning and operations workflow. So here first the increase the model complexity, and we have to add the relevant features and train for more epochs, that is will use more expressive algorithms. So to improve model performance we have the basic steps, that is first thing mainly for training, testing, and data validations. And for next we are going to choosing the robustic algorithm to improve the model, to ensemble the learning, to get the desired outcome by using the workflow operations. So this is a basic key steps to prevent the underfitting. And next thing is to prevent the overfitting is use the regularization method, which is L1 and L2. So apply the cross validations to identify to classify the labeled data, which is whether it is overfitting or underfitting. Underfitting is too simple to explain the variance, and overfitting is to force fitting too good to be true. So that is the concept of overfitting and underfitting. So here we'll use the regularization method, that is L1 and L2, to apply the cross validation. It is mainly used for reduce the model complexity and increase the training data. So this is it will use yearly stopping of overfitting. So here the graphical representation will shows the overfitting and underfitting, appropriate fitting, and overfitting. So here underfitting is for classify, differentiate the which one is simple which is too simple to explain the variance. So which is bias and variance, which has a simple variance, and when appropriate fitting have the biased data, labeled data with simple variance. And in this overfitting it will force fitting too good to be true, which is data will be uh, force fitting too good. So this will represents the uh, increasing the training data to reduce the model concept. So this is the preventing of overfitting. So here the concept of overfitting and underfitting prevention is in supervised learning. So this is the main thing. So next we'll see the next topic in next lecture video. Thank you.